All right, hello once again. This is Jeff Scott of Rankin Technical College. And I am not happy about this, but I will tell you that I was making a presentation for Chapter 3, and somehow I just had a power hit. And it's not where you have a power hit where what takes over is your battery. I just lost everything I was working on, about a half an hour's worth of work, which isn't good, but I'm just going to ramble on. We're into Chapter 3 now, and Chapter 3 has 5 objectives. Storing data in arrays, using loops, and in particular while loops, do while loops, and for loops to repeat code execution. Use continue to restart looping statements, and going along with that, we'll use break to end them. And use if statements, if else statements, and switch statements for selection or decision making. And finally, nest one statement inside of another. All right, so this is what I started doing earlier, and it'll be fine. Okay, so the way that I typically define an array, and this is my definition, an array, a set of contiguous memory locations that each hold the same type of value. All right, now let's change this to a typical array. That would be a typical array. Well, one thing you've hopefully learned in a little bit of time we've been talking JavaScript is not typical. All right, what I mean by that is with JavaScript, you have no guarantee that the memory locations are going to be contiguous. So we'll change it to ideally contiguous memory locations. With JavaScript, they don't have to hold the same type of value. Okay? They can, they often do, but they don't have to. All right? So, the way I'm going to explain this is imagine, you don't have to imagine, I live in an apartment complex in Lake St. Louis, Missouri. It is an 8 apartment complex. It's part of a bigger complex, but the unit that I'm in has got 8 units in it, I guess, whatever you call them. And typically, they're going to be unit 1, 2, 3, 4, 5, 6, 7, 8, but imagine that they started with 0 instead of 1, just to be different or whatever. So what I could do is I could come in with using JavaScript and do this, which would creates what's referred to as a string array. It starts with 0. It's called names, and this is referred to as names sub 0, names sub 1, all the way through names sub 7. There are 8 elements, but since we start counting at 0, it goes from 0 to 7. All right, just so you know, and I'm trying to be consistent here, I could have also said names, var names, equal, and I could have put in brackets like this. My machine's starting to act very odd. Now, I can keep typing all on the same line. The only reason I'm going to another line is I would probably run out of room on the screen. Okay, just so you're aware of that. But there's absolutely nothing wrong with me continuing to type all on the same line. So what you have in front of you here are two different declarations, or two different ways of setting up the same array of strings, typically referred to as string array. In the first case, all I do here is I declare a new array. I don't give it any size or anything, I just declare it. And then I fill the members up one at a time. Now you can imagine that's kind of how an apartment complex would work. People move in at different times. But let's suppose that it's a brand new apartment and all 8 families moved in at once. That would be doing it that way. So again, what I'm telling you here is both of these set up a string array, the same string array. So that's two different ways that you can do the same thing. All right. Keep that in mind, I guess, as we start here. So the author defines an array as a set of data represented by a single variable name. Not bad. Array literal. Most common way to create an array. Declares an array and specifies array as content. Well, that's what I just showed you, where I said var names, and in the brackets I put all of the names. All right, so again, that's one way that this can be done. And they even show an example here on the bottom of the page where they have sections, I guess, of a newspaper. And there's absolutely nothing wrong with what they've done. It's no better, it's no worse than the example that I gave you. All right? I guess if nothing else, you could say it's probably, if for lack of better words, it's very similar to the example that I gave you. All right? So it's var followed by the name of the array, when you do it like this, equals, and then in brackets, not curly braces, not parentheses, but brackets. All right, and there are 1, 2, 3, 4 strings in here. So this would be news section sub 0, news section sub 1, news section sub 2, and news section sub 3. The size or length of the array is 4, but the element numbers are 0, 1, 2, and 3. There's an old joke that says, ask a programmer to count to 10, and they say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? All right. Each thing that we put into the array, and I already showed you, and I said those would be saying like name sub 0 equals Scott, name sub 1 equals Jones, name sub 2 equals Smith, name sub 3 equals Brown, name sub 4 equal Green, name sub 5 equal Black, name sub 6 equal Wilson, name sub 7 equals Anderson. Sub is short for subscript. Each one of these is referred to as a subscript. Each member of the array is also known as an array element. All right? Not only are these called subscripts, they're also called indexes or indices. All right? So, again, that's one thing about computer people. Typically, they can't agree on much of anything. So there's a lot of different names that can be used here. All right. So you already saw in the other example that I gave you how you could assign values to individual array elements. Now I happen to do those when I assign those into the array elements. I did them in order. All right, and you saw that. These were in order. 0, 1, 2, 3, they don't necessarily have to be. There's no guarantee that if I move into apartment 0, that when Jones moves in, they're moving into apartment 1. Maybe Smith moved in before Jones did or something. I just put it there because I thought it was easier to explain to you what was going on. You can create a brand new array without any elements. So I could have, instead of saying var names equal new array, all right, so another way of doing this, just so you know, and I will comment out the first example. We could have also said var names equal bracket bracket. That would have worked as well. So any of those would have worked. Okay? Now, just so you know, when you start to fill up values into an array, those values don't have to be the same type. In other words, if we wanted to, let's say I wanted to add a new element to the array. So I could say names sub 8 equal, and I could put in here 127, and there's nothing wrong with doing that. So I'm mixing string values with numeric values. You cannot do that with arrays in most programming languages. In JavaScript, and PHP is another language that's like that. In both JavaScript and PHP, you can mix data types. All right. To access an element's value, you can do this. Now, don't worry about this. We're going to look at all this stuff, okay? I just take my word for it. We're going to look at this stuff as we go on. To modify values in existing array elements, you include brackets and syntax. So, for instance, one of my hopes is that within a couple months, my wife is going to move down here from our home in Illinois, and when she does, I'm going to leave. So once I leave, the apartment will become vacant. So let's say inside of names sub 0, of course, who moves in there but Johnson? All right, that's totally legit. Totally fine. That's just in the same way that you can replace the occupants of a house or an apartment, you can replace the occupants in an array. If you want to determine how big the array is, all right, and you can say, well, yeah, I could just count. Yes, but you're not the computer. Okay, so if I said in here var len equals names dot length, well, it would count 1, 2, 3, 4, 5, 6, 7, 8. So the answer that would get returned from that, the value inside of len would be 8. Hopefully that makes sense. Now, I didn't write this chapter. If I had, I think I would have talked about loops first, because loops, which we'll get into in just a couple minutes, are natural ways to go through arrays, or also what's referred to as iterate through arrays. All right. JavaScript, as it says, represents arrays with a special array object. This was the other example that I showed you. Okay. We said new array. We could have given it a size when we did that. So in other words, I could have up here, I could have said 8. Would have been just fine to do that. Again, whether it's good, bad, or indifferent, there are a lot of ways in here to do the same thing. All right. We're going to talk about get elements by ID in a later chapter. We're going to talk about get elements by tag name in a later chapter. We're going to talk about get elements by class name or class in a later chapter. So I'm not going to hit on those right now. All right, good. Let's talk about looping statements. JavaScript, like most programming languages, supports 3 types of looping statements: a while, a do while, and a for. And what I want to do here is show you the difference between the 3 of them. So I'm going to take my little drawing and my other stuff here, and I'm going to comment it all out. All right, so let's say that I've got a goal here. My goal is to print out the numbers from 1 through 25 on the screen. So that's what I want to do. In addition, I want to use as few lines of computer code as I possibly can. Okay? So let me show you 3 ways of doing it. All right, the first way that we'll do this is we're going to use what's called a while loop. And we'll say a few things about that in just a couple minutes. All right, so I'm going to let's make a function, and we'll call it while loop. Okay, we have to make sure when we're all done that we call the function, so we'll call while loop. We'll do that next. All right, so I'm going to say var here, and this is one of the few times when you're creating a variable that it's considered permissible to give it just a single letter name like I. So var I, I'm not even going to give it a value. In fact, yeah, I'll give it a value of 1. Okay? So I'm going to say here while I is less than 25. And don't worry what all this means, because we're going to go over all of it. And I'm going to put a semicolon there. I less than 25. I'm writing this wrong. All right. While I is less than 25, what do I want to do? Well, I want to write on the screen, so document.write the current value of I is I. All right, and then I'm going to say I plus plus. All right, let's run the program and see if it says on the screen the current value of I is 1, the current value of I is 2, the current value of I is 3, etc. 25 times. All right, so let's see if this works. Well, something's missing or wrong. Unexpected end of input on line 246. So we'll fix that. Function while loop. While loop. What's wrong with that? Oh, I still have this max value in here. So I don't know if that's goofing it up. I have no clue whatsoever. I want to go back and see how much of this stuff I can just double check. Okay, that was my array stuff. This should be okay. Var I equal 1. While I is less than 25, less than or equal to 25, document.write the current value of I is, and then I plus plus. I mean, the code is fine as far as I can tell. Oops. That's what happens when you open up the wrong file to run. So I've got to run it from here. I've saved. And you see the current value of I is. Okay, we make this a little smaller. There they are. The current value of I is 1 through 25. All right, so you see the result. That's the result I wanted. But let's talk about how we got there. Okay? First thing. All right, while loop. I'm going to put some comments here. A while loop is known as a pretest loop. What does that mean? You make the test, and if the test is true, you go through the loop. When you get to the bottom, you come back up and you test it again. So had we said this, what if we said I equal 26? Okay, I'm going to run the program again. And notice I get no output. And the reason that I get no output, that's not an error. The reason that I get no output is I is 26. Is 26 less than or equal to 25? No, it's not. So I skip it and I fall right out of the loop. That's the first thing. Okay? The second thing, I need to put this line in there. because that is changing the value of I every time through the loop. If I don't do that, so I'm going to comment that out. This is really dangerous, okay? But I'm going to run the program. Now I'm in an infinite loop. Okay? I've totally lost control of the program. It's just spinning away, if you can see that right there. Okay? So, always want to change the value of your loop control variable. So, number one, the first thing that you have to do in a while loop is you have to do what's called initialize the loop control variable. That's what you must do first. Second, you must test the current value of the loop control variable. So I'm showing you this. That's where I'm doing the first thing. That's where I'm doing the second thing. And third, you must change the value of the loop control variable. So these are the hallmarks of using a while loop. It's a pretest loop. And what I end up doing a lot, you don't have to do this. This makes the program, doesn't make it run any better. But quite often, instead of calling it I do call mine LCV. And LCV is just an acronym that stands for, guess what? Loop control variable. All right, and again, the program doesn't run any better like that, not at all. So the current value of LCV is. But you'll notice, and I'll put LCV here. So I've changed all the I's, I believe I hit them all, to LCVs. Okay, the only difference when I run this is it says the current value of LCV is, as opposed to before when it said the current value of I is. But what I want you to understand from this is when you work with a while loop, it's a pretest loop. So if the test is false initially, you never go into the body of the loop. You must declare and initialize the loop control variable. You must test the loop control variable in your while loop. And in the body of the while loop, so between the curly braces, you must change the value of the while loop. So that's the first type of loop. All right. I'm going to go and copy all of this. So all of it's here. The people who are upstairs from me, I don't know what the heck they're doing, but it's like every night I sit there and get to listen to them make noise. I'm so tired of it. All right, so I'm going to go and copy into here, copy it all over again. So this is going to be number 2. And instead of a while loop, we're going to make this a do while loop. Unlike a while loop, a do while loop is known as a post test loop. We still do this, but I'm going to take this line that you see right here, the whole line, copy it or cut it. Oops, try to cut it. Cut it and paste it in down here. And up here, I'm going to put the word do in. So this is going to be called do while loop here and here. So let's save this. Let's run it again. And you just saw what we got back. Okay? So now I'm going to run it again, but I'm going to run another copy of it. So File, Launch, look familiar? There it is from a while loop. There it is from a do while loop. They look, the output is identical to one another. So let's talk about the differences. This is a post-test loop, which means you don't check it until the end. What that means is with a do while loop, you always go through the loop at least once. Always. You have no choice because you don't test it till the bottom. But you're still initializing your loop control variable. You're still testing your loop control variable. You're still changing your loop control variable. So the difference is when we looked at a while loop, you made your check at the top of the loop, so you have no guarantee that you're ever going to go through the loop even once. With a do while, since you make your check at the bottom, you must go through it at least once. So you've seen two of them now. You've seen a while loop and you've seen a do while loop. All right. I'm again going to copy all this, but it's going to look a little different when I get done. All right, and this third one is going to be what's called a for loop. All right, a for loop like a while loop is also known as a pretest loop. All right, and like a while loop, you're never sure you're going to ever go through the body, but it's a little bit different. Notice when we did the while loop up here, we had 1, 2, 3, 4, 5, 6 lines of code. All right, so everything that we did in here, that made up 6 lines of code. Let's see how many we get when we do the for loop. For var LCV equal 1, LCV less than or equal to 25, plus LCV. All right, we don't need a do in there. We still need our document.write, and we have nothing at the end of this. So in the same line of code here, in this line, we first initialized the loop control variable in our line. That's the first thing we did. Next, we tested our loop control variable. And finally, in this same line, we changed the value of the loop control variable. So we did all that. All right, so this one is going to be called for loop. So let's call it for loop. All right, let's run it. Okay, so here's the value. There's the output from the while loop, the output from the do while loop, and the output from the for loop. They're identical to one another. All right, a for loop, just so you know, you may or may not care, a for loop is also known as a counting loop. Okay, that'll make more sense a little later, but I just wanted you to hear that. Okay, so now if we jump back into our book, I just showed you the while loop. As it says, the while loop repeats a statement or series of statements as long as something, a condition, evaluates to true. So while this expression here is true, keep doing it. Your counter is typically incremented, but it could be decremented. If I wanted to, let's say I was doing a countdown for a rocket launch, I could go down from 10 to 1 or 10 to 0. Okay? You can use the while loop with an increment, a decrement, an assignment, a lot of ways. Here they're just printing out 5 numbers. It's pretty similar to what I just showed you. But again, notice initializing the loop control variable, testing the loop control variable, changing the loop control variable. All right, and here they're doing it but in reverse, but still initializing, testing, changing. As they showed you right here, if you don't change the value of the loop control variable, you get what's called an infinite loop. Not a good thing. Very rarely, if ever, is that desired. Sometimes, though, it is. We won't talk about that right now, but sometimes it is. All right, another different example of a while loop. Next is the do while. Okay? Always executes the statement at least one time. So do, and then you do the statements, then you check to see whether it's true or false. Couple of examples. Again, I think the examples that I gave you hopefully at least will suffice. The for, again, also known as a counting loop. So in the same statement, you initialize your loop control variable, you test your loop control variable, and you change your loop control variable in the same statement. Now this is an important slide right here, because the author says these are the steps, and it's not just when the JavaScript interpreter encounters the for, it's when any language encounters the for. Again, step 1, you declare and you initialize your loop control variable. In step 2, you evaluate that variable to see if you should continue on or not. If the value returns true, you do the steps that are inside of your curly braces, and you go, you get down to the bottom curly brace, and you go back up, and then you add 1 or subtract 1 from your loop control variable and test it again. That's how it works. So, I mean, you can use this in a lot of different ways, and they give you examples. I don't think that any are any better or any worse than the example that I gave you. Let's look at continue, okay? And it really won't matter when we do this. All right, but when we use continue like this, it really and truly won't matter which of these loops we use, okay? But what I'm going to do is I'm going to say this. If the loop control variable is equal to 17, that number means nothing. I just said it. Break. Okay? So let's see what this prints. I added this. Remember, this was our output from our for loop. It was right here. Okay, let's change it. We just did change it to see if it was 17 break. So now let's see what the output is. Okay, when you hit that value, you break out of the loop. Now, it's never recommended that you prematurely break out of a loop, but if you have to for some reason, you can use the break statement. Now, let's change this. So now, I'm going to comment all this out. What I should have done before I commented it out was to copy it, but that's okay. Okay, so I'm going to put a copy of this right underneath where we just had it. So I'm going to paste that in, and I'm going to uncomment this. Now I'm going to say if LCV equals 17, continue. So previously I said break, which got us out of the loop. Let's see what continue does. So let's run this one. You see they're all there. And in this case, it does look like they are. Did I save? I'm gonna close this one that I just ran. Did I save? Yes, I did. Did I save this one? Yes, I did. If LCV equals 17, continue. Oh, it's already printed out the value. So I've got it, if I'm going to check this, I've got to check it before I print out the value. Okay, so let me check it up here. Okay, now let's take a look and see what prints out. (15, 16, 18). So continue cancels the current loop iteration. And then it goes back up to the top. So when it finds out that it is 17, it doesn't print out the value. Instead, when it hits the continue and then the curly brace, it jumps right back up to here. Adds 1 to it, so it's 18, then it starts printing again. All right? Now, had I moved this up to the top like this one, then it would never have printed out 17. Okay? All right. Some really, really good stuff in here. So again, I showed you the continue. All right, let's talk about making decisions. And guess what? You've already seen this. We've already looked at the if statement. All right, I'm going to give you a kind of a neat little program here. Okay, I've just decided like that right now to do this. So this is either going to be really neat or you're going to be like, what? So let's do this. All right, we're going to call this function odd or even. What is that? What do I mean? You're going to find out in just a second. All right. First thing I want to do is I'm going to close all these things that are open. I don't need any of them right now, okay? And I'm going to come in here and I'm going to say random number 1 through 10 JavaScript. Okay, and let's see. I know they're going to give me, there's an example. So I'm going to do this, and don't worry about what it means because we'll go back and take a look at it in just a minute. All right, so var num equals, okay, if num modulo 2 equal 0. Oopsie. Oh, sheesh. Document dot write the number plus num plus is even. Else the number is odd. Okay, now we're going to use one of the nice little tricks that we just did where we just learned how to use a loop. So for var I'll use LCV equal 1, LCV less than or equal to 25, LCV plus LCV. Okay. X, we're going to have to make a couple changes to this, but not too many. All right. Oops. All right, let me run it first, then we'll come back, I promise, and we'll go over the entire program. If I did it right, we're going to have 25 numbers, and it's going to say 25 times the number is odd or the number is even. So let's see. Not if I run it like that, though. You always have to make sure that when you run this, you're running the HTML file. There we go. All right, so I've got numbers between 1 and 10. Now, probably I'd like a little bit more variation than this, so rather than saying from 1 to 10, I would have probably been better off to say 1 to 100. Okay, so let's go where we just ran the program and let's refresh the browser. There we go. So if you look at these, ideally at least, unless I made a mistake, which I don't think I did, you've got 25 numbers, and each number is either odd or even. Now, some of the numbers could be repeated. There's nothing to stop that from happening. But if the number is odd, it should say the number is odd, and if the number is even, it should say the number is even. So how did we do all that magic? Well, first of all, we created a new variable in here that we called num. And then we said, what this says, let's put a comment in here. This says, do this 25 times. How do we know that? Because we're telling it to go from 1 to 25. All right. This says, whoops, generate a random number between 1 and 100. All right. This says, if the generated number is evenly divisible by 2, all right, write out that the number is even. If the number is not evenly divisible by 2, write out that the number is odd. All right? When you run a random number function with any kind of computer program, you get a random number that's greater than 0, all right, and is less than or equal to 1. So you might get 0.63857, for example. Okay? So what we're saying is, whatever that number is, let's say it is. So let's say that we generate a number, and let's say the first time it comes out to 0.638997. We get that. Then we take that number and we multiply it by 100. All right? So it changes to 63.897. Then we say throw away any remainder part. That's what the floor does. So that's what we've done. So 25 times we're saying generate a random number between 1 and 100. Then if that number is evenly divisible, so there's no remainder, if that number is evenly divisible by 2, all right, if it's evenly divisible by 2, then write out that it's even. Otherwise, that's what the else is. Write out that it's odd. Pretty simple stuff. All right, you saw it. If I run this again, I should get out 25 different numbers. And I can keep doing it. All right. So that's one way of making decisions. And I just showed you there's an if. So if we only wanted to print out the even ones, we could have done that. So notice, if I remove this else by commenting it out, so I'm commenting out all the else part that we put in there. All right, and I'm going to run the program again. We will probably not get 25 numbers. We get about half that many because we told it to only print out the evens. So an if without an else does something if it's true and does nothing if it's false. Again, I can keep doing this. Sometimes I'm going to get more, sometimes I'm going to get less. But I should never get much more than 15 or so. So I just showed you the if-else, so you've seen what that is. Again, some of the examples that they give are just, for lack of better words, they're kind of silly. All right? Okay. Nested if-else statements. If you remember, okay, if you remember quite a while back, we looked at, and I'm going to grab that because by now it's commented out, I'm sure. Here we go. A long time ago, we talked about going to a party. Let me comment this out. Okay, so a long time ago, we talked in here about having a party. Okay, and I said this. And I mentioned that to go to the party, we said you must be 21 and you must be a member. So let's look at that one. Okay? So both those conditions are true, must be true. So one way I could write it is like this. Another way I could write it would be to say if age greater than or equal to 21, then if program equal to AWD, then do something. So in this case, these two are together. It's going to check both of them. In this case, it'll check the age, and if the age is less than 21, it never makes this check. Only if the age is 21 or above does it make this check. So the difference between these two statements are, the first one is a single statement, and the second one is a nested if. It's an if inside of an if. All right? Now, hopefully that means something to you, but you know what I'm going to try to do here? Is I'm going to try to show it to you a little bit in another way. I'm going to build a clock. So I'm going to have function clock, and I'm not going to have nested if statements, but I'm going to have nested while loops. So I'm going to call clock when I get all done. All right. So I'm going to have three variables, var, and I'm going to call them hours, var minutes, and var seconds. You know what those mean. I'm trying to use words that would make sense. Okay? So I'm going to stay in here. I'm going to have three loops. My first loop is going to count, and it's going to say for hours equals 0, hours less than 24, we're going to use military time, plus hours. They've done studies, and plus hours executes faster than hours plus. Now inside of here, I'm going to have another loop. So let's put a comment here. Whoops. And this comment will say hours, because that's figuring out the hours. This one will put a comment in here, and this one will be for minutes. All right, so for minutes equals 0, minutes less than 60, minutes, or plus minutes. Okay, so that's my second loop. Then inside of here, I'm going to have another loop, and that loop is going to, that loop is going to handle the seconds. Okay, so I've handled the hours, I've handled the minutes, and now I'm going to handle the seconds. Oops. All right, so what I'm going to write in here is, and this is going to look real big, but I'm going to say, for lack of better words, document dot write hours. Let's just, we won't write any comments. We'll just write hours followed by a colon, followed by minutes, followed by a colon, followed by hours, followed by a line break. All right, let me run it first, and then we'll come back and we'll take a look at the entire program. So just let me run it first. Well, the good news is that it's running. The bad news is it's giving me the wrong answer. So let me check my stuff here. Hours 0 to 24 plus hours, minutes 0 to 60 plus minutes, seconds 0 to 60 plus seconds. And that actually looks correct. Hours equals 0, hours less than 24 plus hours, minutes equals 0. Minutes less than 60 plus minutes, seconds equals 0. Seconds less than 60 plus seconds. Write hours, colon, minutes. Oh, I should have said seconds here. If you already saw that, you're a leg up over me. So let's run it again. And there's our clock. 0 seconds, 1 second, 2 seconds, 3 seconds. Now notice when it gets to 59, then it's 1 minute, 0 seconds. When it finally gets to, this will be a while, so let me move this down quite a bit. So here we're at 48, 49 minutes, 50 minutes, 51 minutes, 52, 53, 54, 55, 56, 57, 58. Now we're at 59 minutes. So notice, then we're at 1 hour. So we're basically doing a clock. I could do a little bit of work here and make sure that each one of these took up 2 spaces. So this would say 0, 1, 0, 0, 0, 0, etc. The point, though, is this. With how many lines of code? Literally 15 lines, maybe, not even. We wrote a fully functional clock. So this goes 0, 0, 0, 0, 0, 1, 0, 0, 2, 0, 0, 3, 0, 0, 4, until it gets to 0, 0, 59. Then it becomes 0, 1, 0, 0, 1, 2, etc. Eventually, it's at 0, 59, 59. Then it becomes 1, 0, 0. So what I'm showing you is by nesting a for loop within a for loop. So nesting this for loop within this for loop within this for loop, how easy it is for us to write something like a clock. And it's hopefully starting to show you the power of using something like this. Okay? All right. They talk here about else-if constructions, and I should be. Let's go back. I think we've looked at our clock here enough, so let's comment out our clock, and let's go back to the program that we just looked at. That was the odd and even one up here. Okay, and let me comment this back out. So. That's not right. Okay. All right. Now, if you remember what we did here, we uncomment this stuff. We had the number is odd or the number is even. Okay. What if, let's go back and change that back to 10. And I'm not going to put +1. Now I'm going to generate a random number that's between actually 0 and 9. All right? So the first thing I'm going to say up here is check for a randomly generated 0. So I'm going to say if num equal 0, what I'm going to put here is document.write 0 is neither odd nor even. Line break. All right. But I can't have 2 ifs like this. I could, but it wouldn't do what I wanted it to do. So I say here else if. So if this is true, do this. If it's not true, then check this one. So if it's true, do that. And if this is false, and if this is false, do this. The key thing about working with if statements, either that's true and all that gets executed and you skip every bit of this, or that's false. If that's false and this is true, you skip the if and you do all this. All right, if that's false and that's false, you do all this. And I guess I've got to comment those back out again. There. So let's see if we run this now, if we get 0 is neither odd nor even at all. I don't know if we will or not. Well, looks like I've goofed up again. Unexpected token in line 360. So let's look and see what that is. Close a couple of these here. Line 360. Oh, well, look at that. That's what it was. So let's try running it again. Still doesn't like it. Not sure what the problem is, so let's take another look at it. And guess what I did? I took the call to it, it's right there, and I commented that call out, so I never was calling the function. All right, so let's try it one more time. And you see that at least once or twice here, we've got 0 is neither odd nor even. We run it again, we might end up getting more. 2 again, there's 2 again, there's 2 again, and again, and again. It looks like we're kind of, oh, there's 3 of them. But the point is, again, when you have an if followed, you can have as many else ifs as you want. You don't need to have an else. You can just keep having else ifs, but you can have only one else, and the else must go on the end. Again, these aren't my rules. These are the rules of the syntax of the language. All right. Is the switch all we've got left? Yes, it is. So let's look at the switch statement, which is kind of another way, at least at times, where you can write an if. Another way to write an if. So I'm going to comment this all out again. And I'm going to write another program here, another function. We're going to call it show size. And we'll have to make sure we call show size. Okay. So I'm going to have var here size. And we're going to ask the person. In fact, we'll do it like this. Let's put it in a loop. We'll put this into an infinite loop. Okay, so it will run forever. You don't typically do this, but we will. So we'll say while 1, which typically is a way of writing an infinite loop. We're going to say size equals parse int prompt, enter a 1 for small, a 2 for medium, a 3 for large. Okay? So that we're telling the person what to do. We're not even going to give them a default value, but that's what we're telling them to do. All right? If size equal 1, document dot write you are size small. Okay. Else if size equal 2, you are size medium. Oops. Okay. Else, if size is 3, we're going to write you are size large. And finally, we're just going to have an else here. Your size is unknown. Okay, let me see if this works. So enter a 1. It's not printing though. 2, 3, well, something's goofed up here. So let me stop the run. I think I know what it is, but I'm not sure. And we're over an hour already, so I want to finish this up. I'll tell you what, I'm going to stop it right here, because these tapes shouldn't be much more than an hour long. So this will be part 1, and I'll come back with part 2, which will be much shorter in just a couple minutes.